All right, so functions and function notation. So I should show you the top of the Cornell notes. So functions are a way to write rules, although they have an equal sign. They're not equations, and they can't be solved like you solve equations. We can simplify them, but we can't solve them. So they show and explain an equivalence that can be evaluated, but should not be treated as equations unless you replace the function notation with its equivalent to variable equations. So as we see in the main notes, we have f of x. This is how we read it, f of x. So it means the function rule of x, where we're going to see variable x, okay? So the rails and expressions, and f of x, what it really means, it can be replaced with y. So if I want to do an equation, I would replace the function notation with the y equals. So because a function is an equivalence, the left side is the information. It's the rule, the variable that we're going to use, any replacement that we're going to do, and its name. So the f or the g or the h is going to be its name. It should not be changed while evaluating, so you're going to keep the whole left side exactly the same, and then we're going to simplify or do anything that we want to do with the right side, with replacements and stuff like that. So if we give you a, if I can find my pen. All right, so if I write, let's say, f of x equals 5x squared minus 3x minus 2, that is telling me that the rule f that I'm going to use right now with variable x that you're going to see is going to be the expression 5x squared minus 3x minus 2. So labeling what we have, my pen's not cooperating. This is your name. Here's your variable, which is also the input. Okay, so generic, it would be the x. And all of this is your rule or expression. And in this case, it's with input x. Okay, so if you want to evaluate a different input for the expression, that's when we're going to change something on the left side, and then we're going to show it working in the right side. So if I want to do, okay, I have my f function, which we've defined up there, and instead of x, I want to say, what happens when you put a 3n in there? All right, so that means that I'm still looking at that rule 5x squared minus 3x minus 2, but every time I see an x, I'm going to replace it with a 3n. So my problem's now going to look like, if it helps, use a couple different colors. Keep what you were originally, what was in the equation. That's not the x in one color, so I'd have the 5. And then I'm replacing that x with the 3n. Keep your parentheses because you're replacing it. It will help with order of operations. And thinking of, oh, what's that squared attached to? Oh, it's everything in that parentheses. We'll look at some of those old rules as well. And then I've come up to another x, and this is going to be a 3n. And then the rest of my function, my rule, is going to be 2n. I mean, just 2. Sorry. All right, so what I do with that, so f of 3n does look like this, where I've done the replacements, and then now what I want to do is I want to make it look a little cleaner, look like there's less stuff to do, simplify it. So we're going to do our order of operations, but we're only looking at the right side. So I'm going to keep my equal sign. Order of operations tells me to do the exponent first. So this is going to be 5, and then this is going to be 3n times 3n. So this is 9n squared minus, I'm just going to write the rest of it. It's 2. And then order of operations would tell me to multiply or divide as I go across left to right. So that is going to give me, let's use this color. 5 times 9n squared is going to be 45n squared minus 9n minus 2. So, and that just equals what was left on the left side. So I could say f of 3n is the same thing as the expression 45n squared minus 9n minus 2. All right, so what we have is we can do some examples with what we're using with this. So we're just evaluating, we're understanding that the functions mean the rule, and then we're really only working with that right side when we do our replacements. So we have a bunch of functions here. So I'm going to have my f function is going to be 3x plus 2. My g function is 5x, and my h function is 2x squared minus x minus 6. And then I have all kinds of different things that I can plug into it. Remember, when you're plugging in, it's replacing that x, and keep your parentheses when you're changing that x. If you need to, use a couple different colors. It tends to work a lot better when we're doing this. And then soon we'll do some extra operations with it, like add them and stuff. All right, so f of 5 tells me I'm using the f rule. So it's going to be that 3x plus 2. And instead of the x, I'm going to put a 5. So this is going to look like 3 times 5 plus 2. I can actually do this because this is all numbers now. So 3 times 5 is 15 plus 2. So this equals 17. So f of 5 is equivalent to 17. So it equals it. All right, so doing a little bit more, I'll leave G of 2 for yourself. I will put the answer key when I upload this. You will get the answers for it, but take some time and try to do G of 2 yourself. And then we're going to look at H of 3. So that tells me we're using the H function, and we're going to replace every x that we have in the H, which is that 2x squared minus x minus 6, with a 3. So this is going to become 2. And then I have the x, so I'm going to replace it with 3. Keep your parentheses squared. Minus, I have another x, so I'm going to put the 3 there, and then minus 6. Doing your order of operations, this is going to be 2 times 9. I'm going to keep parentheses for my multiplication. Minus 3 minus 6. I could have done that 3 minus 3 minus 6 together if I wanted to. So this is going to be 18 minus 9. Or 18 minus 3 minus 6. We can do it just one thing at a time as we're going across. 3 minus 6. So 18 minus 3 is 15. 15 minus 3 is 9. So my H of 3 equals 9. All right, so be careful when you're plugging stuff in. If you have a negative number, that can change everything. So we'll look at the H of 2. Yeah, it's another H equation, but it'll work. So this one, every time I see an x, I'm going to replace it with a negative 2. The parentheses really will help you in this case because that negative is part of what you're substituting in. So I have 2 of negative 2 squared minus a negative 2 minus 6. So this is where we're remembering all of those rules of arithmetic with positive and negative numbers, order of operations, and all of that. So there's a lot of stuff that we're pulling back from previous classes. So this is 2. Negative 2 times negative 2 is a 4 because a negative times a negative is positive. A negative 2. So that means the opposite of negative 2 is going to be a positive 2. And then I have a minus 6. So 2 times 4 is 8, plus 2 is 10, minus 6 is going to be 4. So 10 minus 6 is 4. So H of negative 2 is just 4. So we're really only working that right-hand side, simplifying as we can. The last one that we're going to do in the video is going to be that G of 4x minus 7. So we can plug in a whole bunch of extra stuff into a function as well. So this means I'm going back to the G function, which is that 5x. So, and I'm going to replace every x that I see with parentheses, that 4x minus 7. So I have a 5, and then instead of the x up here, I'm going to be putting that 4x minus 7. And yet again, I'm not doing anything with that right side. That's just telling me what I want to do and what I want to substitute in. And now I have to do order of operations. I have that 5. Remember, there's the times here. So we're going to distribute that. 5 times 4x is going to give me 20x. And then that 5 times negative 7 is going to be a negative 35. There is nothing else I can do. So I can just say G of 4x minus 7 is equivalent to 20x minus 35. So Make sure you ask questions if you have them, and then make sure you do the last two problems before you check the answer key.